ASTRO-403 research project. So an overview of our project was, the objective of it was for it to be a research project that analyzes optical MDM data and SWIFT observation data in order to compose a report and personal presentations from each group member that would relate to our research topic and would be similar to the methods of an expert specialist. The mission was to ascertain the know-how that allows us to utilize various data analysis software like Heliosoft, Midas, and Linux to deliver the information into usable configurations that would provide a window into our assigned AGN. The three main parts of the project. The first is the optical MDM data analysis and wavelength calibration using the Midas software. The second is the SWIFT data reduction and analysis using Heliosoft. And the third is the literature search and paper composition. My responsibilities for the project was the literature search and the paper composition. This was due to my laptop being broken and only having very limited access to a computer in the Space Science Center. So the group agreed that it would be best if I took over the literature search aspect of the project as well as creating a detailed outline or skeleton for the paper. While I did not actually play a role in the data reduction, I still did constantly have to keep up to date on how the other members of the group were doing and what they had accomplished and what results they were obtaining to better perfect the outline. I also played a role in the actual data analysis. The first step for me was creating a working outline. Before I gathered any information on our source, I read quite a few papers that were similar in topic to our project topic in order to formulate a basic outline that would not only help me decipher what information is and is not useful in the various papers that I would come across, but also allow me to slowly build on the paper over time, rather than trying to type it all out last minute. One of the papers that was especially helpful in helping me create this outline was the single source paper that you, Dr. Grupa, posted on Blackboard for us to look at. The outline followed a general structure for academic and scientific papers, but more specifically, it followed the astrophysical journal style and was created in overleaf. The basic paper outline was as follows. It consisted of 6 different sections. 1, the abstract. 2, the introduction. 3, the observations and data reduction. 4, the results. 5, conclusions and discussions. And 6, the acknowledgments and references. Now, even though the abstract is listed as first, generally it is composed last due to the fact that it contains some information from just about every section in order to give a possible reader an idea of what they're getting into rather than having to read the whole paper to find out. The literature search. Knowing that I was going to be sifting through a lot of information, I had to approach this from a professionalist perspective rather than a typical research paper like I am used to doing. The literature search proved to be a very arduous task due to the massive amount of information and papers I had to sift through to find the information that was actually pertinent to our topic. I found the NED and the ADS to be especially helpful in finding the various papers that reference our AGN, as well as some basic information and overview on our specific object. I tried to implement the step-by-step method of reading a scientific paper given by Dr. Jennifer Raff, which you posted on Blackboard for us to use. I actually found it to be very helpful in, I guess, just helping me realize what was and was not important, but also what you could and could not trust. It made it kind of easier to pick out little patterns that you would see in papers that maybe weren't the most viable options. On to our object. PG 2304 plus 042. Now, this is the name that we were given from the start, but it does have other names that it goes by. 2 of them are Swift J2307.1 plus 0433, which was especially useful because the Swift data, actually going to Swift's site and looking at the data they have on it, allowed me to compare that with what I found on the NED as it was labeled under the PG 2304 plus 042, and make sure that everything lined up. And it was a way for me to constantly double check that I was using the right source. The other one is PG 2304 plus 043. This confuses me a little bit, that it's only off by one small number, which I also noticed that the plus 042 almost seems like it comes from its value of its redshift, which is 0.042. I don't know if there's a correlation there necessarily, but it was interesting to me to find out that the PG 2304 plus 043 was the same object, essentially. It also has various other names, including these other three, which there's no point in me saying them out loud. You can read them. History of PG 2304 plus 042. According to the NASA/IPAC Extragalactic Database, or NED, as I mentioned before, the first reference of our object, PG 2304 plus 042, was in a 1980 paper by Berger J. and Frangent A.M., which cataloged a number of stars and compact objects. I sifted through countless papers trying to find when this AGN was first discovered or observed, and the only conclusive evidence I could find is the above-mentioned paper. I know it was discovered earlier than the publishing of the above paper because it was mentioned as a reference in a different paper under its PB classification, which, if I'm not mistaken, is PB 5250. But I couldn't find it in the actual paper. It was one of the referenced ones, but as you go in there, you see 5249 and 5251, but there was no 5250, which I found to be kind of odd. The NED classifies our source, PG 2304 plus 042, as both a G-type object and a Seyfert-1 galaxy, specifically of the Seyfert 1.2 subset. In a paper comparing NLS-1 galaxies, or narrow-line Seyfert-1 galaxies, and BLS-1 galaxies, or broad-line Seyfert-1 galaxies, I was able to find mention of PG 2304 plus 042, referring to it as a broad-line Seyfert-1 galaxy. I found that to be interesting because we haven't done much with any broad-line Seyfert-1 galaxies. Most of our homeworks, exams, and PowerPoints have mostly talked about narrow-line Seyfert-1 galaxies. The following image on the next slide is of PG 2304 plus 042 in the optical spectrum, and it was captured by the Palomar 48-inch Schmidt telescope. I found this to be very interesting because when I first saw the image, for a split second, I thought I was looking at something under a microscope. That's what it looked like to me. But so some basic info about PG 2304 plus 042 is its right ascension is at 23 hours, 7 minutes, 2.912 seconds. Declination is 4 degrees, 32 arc minutes, and 57.22 arc seconds. Has a redshift of 0.0420, which again, I found to be interesting that the plus 042 just happens to be the same thing as that, which I feel like there is a connection there, but I never found anything conclusive about it. And the approximate black hole mass that was actually calculated by us, the two values were varying between 6.69 times 10 to the 7 solar masses and 8 times 10 to the 7 solar masses. So I put them both in there. Another little extra thing is, while it doesn't really have much to do with our AGN specifically, I did find it very interesting that while SWIFT is dedicated to gamma-ray burst science, its instruments that allow for its observation of GRB afterglows work very well for observing AGNs due to their similar types of emissions.